is something called as cardinality. Cardinality is nothing but the number of elements in a given set. So if I have an infinite set, what would the cardinality be? Pretty simple, right? Infinity. So we don't typically talk about cardinality of infinite sets because you can't count the number of elements. Cardinality is nothing but the total number of elements that are present in a given set. So any finite set, list out the elements, count the number of elements, that would be the cardinality. Right? So if you take a typical cricket playing team, there'll be 11 players in the team, so the cardinality of that set is going to be 11. That's all that cardinality. When I was closely following the much hyped India-Pakistan match, I noticed that Virat Kohli was the only Indian who scored a century in that match. So if I were to make a set of all Indians who scored a century in that match, we'd have only one element in that set. We call such a set a singleton set. A set with only one element, Virat Kohli in this case. Now, in the same match, what if I were to make a set of Indians who took 5 wickets? Is there anyone who did that? Unfortunately, no. So this set would be a null set. A set where there is no element. This would be a null set. A set without any element. Let's consider the playing 11 of the matches against Pakistan, South Africa and UAE. We observe that most likely everything should be the same. So if you observe the teams for matches against Pakistan and South Africa, they are exactly the same. We call such sets as equal sets. Both the sets are exactly the same. Now, if you look at cricket, it's equally important to analyze the performance of opponents when we are having a discussion about our team. So let's consider the set of teams that India played against in this World Cup. Right? So if we put down the set of all teams, each element of this set is a set in itself. Right? Australia is the set of Australian players. South Africa is the set of the entire South African team. Pakistan is the set of the Pakistan team. So every element in this large set that we have here is a set in itself. So we call such a set of sets. Right? Because every element is also a set. It's not just an object, it's a set. So that is set of sets. That's the next new word for us. The next thing we come to is something called as subsets. The name tells you something, right? It's a set and then I take a part of it and I call that a subset. Right? Suppose I write a set 1, 2, 3, 4, 5 and now I take a part of it 1, 2, 3. 1, 2, 3 would be a subset of 1, 2, 3, 4. Correct? Nothing but a set in which subset is part of a set. So let's say we have a set of all the players who are part of the squad for the Indian World Cup. The entire set. So that is our main set. Let's call that Team India. Now from this, if I want the set of 11 players who played the Pakistan match, that would be a subset. Right? These 11 players are picked from the above set. Such a set is what we call as a subset. So this set here is called a subset and this set on top is called a superset. So if I had a set 1, 2, 3 and I have one more set 1, 2, 3. So they are equal sets. Equal sets are also proper subsets of each other. A subset simply means every element in the subset should be present in its superset. Right? That's how we call supersets and subsets. Let's try to take a small simple set and write all possible subsets of it. So let's say we have set A with elements 1 and 2. One subset would be the null set. A set with nothing. The null set is actually a subset of all sets, right? Because everything contains nothing. So first would be the null set. Then we can have a set with just 1, a set with just 2, a set with both 1 and 2. So it's the null set and the last one is the equal set. So all of these 4 sets are nothing but subsets. So there are 4 subsets of set A. Now a set of all of these 4 subsets is what we call as a par set. A par set is nothing but the set of all subsets. So it's a set of sets, it's a set of all subsets. How many subsets does A have in this case? 4. 4 is nothing but 2 squared, right? Why did we get 2 squared? Because the cardinality of our original set is 2. It has 2 elements, 1 and 2. That's why you'll always get 2 raised to the cardinality. Let's try out one more set. Let's say we have set B with elements 1, 2 and 3. Now what would all the subsets be? We'll have the null set first, then just 1, just 2, just 3, then 1, 2, 2, 3, 1, 3, and finally 1, 2, 3. Now how many elements did you get? How many sets did you get basically? 8. Right? There are 8 possible subsets. So your par set will have 8 elements, each of which is one of these subsets. 8 is nothing but 2 raised to 3. You got the same thing again, right? 2 raised to cardinality. So the number of elements in your power set will always be 2 raised to cardinality of the original set. It's nothing but a set of all possible subsets, starting with a null set, ending with an equal set or a proper subset. That is what a power set is. There is one superset of all sets, something we call a universal set. If we are discussing about the World Cup, a universal set would be set of all the players who played in this World Cup, right? From all the countries, all the players together. That would be a superset. Any discussion regarding players in this World Cup would involve players from that set, right? Any different sets we make of players would involve players from that set. So for this discussion, the universal set could be the set of all players who played in this World Cup. So universal set is nothing but, in very simple words, a superset of all possible sets that we are going to discuss. It need not be one universal set, could be all cricketers. Another universal set could be every person who has ever played cricket. They're all universal sets, right? Another could be the entire population of the world. That is the final universal set, right? Any human being you pick has to be from that set. But for typically what we take as a universal set is only that part which is relevant for our discussion. There's no point in taking everybody who's there in the world, right? If you're talking about the Cricket World Cup, universal set sufficient to have just the people who played in this World Cup. So that is what a universal set is. It will basically be a superset of any other set you're going to talk about in that particular discussion. So in the numbers that we've learned so far, real numbers is our universal set. All the other number types that we discussed are part of real numbers, right? So natural numbers is a subset. So if I take real numbers as my superset or universal set on top, natural numbers is a subset of that, whole numbers is a subset of that, integers is a subset of that, rational numbers is a subset of that. All of these are subsets, right? So for this discussion on numbers, what we've learned so far, real sets would be a good enough universal set. You will soon this year learn something called as complex numbers. Then real numbers won't be enough. Real plus complex you will have. So you will require a new universal set. But all numbers you've learned so far, real numbers is a good enough universal set. So that is what a universal set is. It is the superset of all sets you will ever be discussing. Right? So that's the universal. Now when we are typically talking about sets, it's much easier if we can start visualizing them. Rather than treating sets as just, list of players or a definition of the common property in set builder form, if you start actually visualizing them, it becomes much easier, especially when you start doing math with sets. Till now, it was all fun and frolic, right? We were discussing cricket primarily. Hardly few definitions in sets. It was primarily a cricket discussion. Now, when you start doing math on this set, if I take 2 of these sets and ask you to add them, subtract them, do a bunch of stuff, it's going to be far harder if you're dealing with a list. It's much easier if you visualize. So how will we visualize a set? Let's draw this out. So let me draw all of this out for you. How will you visualize a set? Simply as a circle. Any set. So you have 3 sets, take 3 circles. That's it. Now, can you take any 3 circles? Can they be any 3 circles anywhere, or should they be in a particular shape and form? Are there any rules? Let's try and see. Let's say we have 2 sets. Set A is all players in the World Cup. We're talking about this World Cup alone. And set B is players in the Indian World Cup. Now, if I draw set A here, this is World Cup, and set B here, which is players in the Indian team. Is this a correct representation? Where would you write Virat Kohli's? My favorite guy, right? I keep coming back to him. Not really, but just an example. So where do you put him? You should put him in set B for sure, but you should put him in set A also. Right? Every player, in fact, who is in set B, every player who was in the Indian team, obviously was also there in the entire World Cup thing, right? Now, you can't write a player two times. The rule is whenever you draw a diagram, every player should be written only once, or every object or every element should be written only once. You can't write them in multiple places. Then it's not a correct representation. So, where should we write Virat Kohli? Here or there? Ideally in both places. How can we sort this issue out? If you take this circle and actually make it smaller and put it inside this circle, then it's perfect. Now, automatically, every player in the Indian team is also a part of the larger World Cup team, which is what is true. So this is how you draw the diagram. So the way you position the circles with respect to every set is a circle. That is simple. The way you position these circles with respect to each other changes depending on what the relationship between the sets is. Now what this also tells you is the Indian World Cup team is a subset of all players in the World Cup, correct? That is why you see it is a subset, right? That is why the Indian set is coming inside the entire World Cup set. That's what you mean by subset, which is very clear in this diagram. So all subsets will actually be represented like this. One bigger circle, inside that a smaller circle. Let's try another example. So in this example, we have team A, which is the set of Indian batsmen, so that's this circle, and Indian bowlers, which is this circle. Now, where would you fit in somebody like Raina or somebody like Ravindra Jadeja? They should be classified as both batsmen and bowlers. Right? They're all-rounders of sorts. But you can write a player only once, so we can't write their names in both the circles. What do we do? Can I take this circle and put it inside this circle, the way we did earlier? That would not be true, right? All bowlers are certainly not batsmen, right? You wouldn't want to call Nehra a batsman. So what do? So there is some intersection, so we bring these circles together. There's some intersection. There are some people who are both batsmen and bowlers, but not everybody, right? And this in-between part is where you can fit in both Jadeja and Ram. So such a set, this part in between is called the intersection. It means exactly what the simple English word intersection means, right? Where both the sets combine. So these are sets, they are not subsets of each other, but there is some overlap between them. There's some overlap. There are some people who belong to both set A and set B. That would be all-rounders in this particular case. So this part in the center that you see, the highlighted part, is nothing but the intersection. This is called the intersection of the two sets. Now, opposite of intersection, while we are at it, we have another word called as union. Union is nothing but combination of both the sets together. So the union of sets A and B here would be somebody who's either an Indian batsman or an Indian bowler. That would be the union. So basically a player in the Indian team, in this case, right? So this highlighted section, if we highlight everything together, that would be the union. Everything which is either in A or in B. It could also be in both A and B, that's not a problem. But it should be in at least one of the sets A and B. That is called a union. So that is union and that is intersection. Now, what if we had two sets? Set A was the Indian team now, and set B was the Australian team. Indian team, Australian team. Do I need to do anything? No, right? They can be two separate circles, nice and easy. There's nobody who's both in the Indian team and the Australian team. Correct? So sets like these do not have any intersection at all. I'm leaving both of these circles separate. I don't need to combine them because there is no intersection between these two. Such sets are what we call as disjoint sets. Disjoint set means there is no intersection. There is nobody in the intersection. Now, if you were to represent it mathematically, an intersection you represent it with an inverted U, and a union you represent it with a U. So this is intersection, this is union. In this case, which is disjoint set, the intersection of A and B is a null set. That is, there is nothing in the intersection of A and B. So that is intersection, union, and disjoint.